everyone, thanks for joining another Cyber Skyline Live. I'm Franz Payer with Cyber Skyline, and I'm here to help you learn about cybersecurity. We run these episodes for you, so please stick to the end and let us know what topics you want to cover next. This week's topic is coding basics. So I'm going to jump into my slides, but please ask any questions you have along the way as we walk through today's show, and I'm happy to answer them. So without further ado, let's get right into it. All right. So, as we get into these code basics, the very first question we're asking ourselves is, what is programming? And very simply, programming is just the process of creating instructions for a computer to follow. And just like how you might follow a set of instructions in a recipe to cook a dish, or maybe you're making cookies, whatever it is, you are following those instructions to accomplish a task. Computers will also follow the instructions that are provided in code to complete the task that the author described in the code. And when a computer follows the instructions in a code, this is often referred to the computer as running a program or executing a program or an application. So if coding seems very complex and convoluted to you, it's just a very simple set of instructions. It's just like if you read a cookbook, except instead of giving instructions to a human, we're giving instructions to a computer. And that has several caveats that we need to consider. Now, let's understand, how does code actually work? Like, what is actually happening behind the scenes? You have a computer and you're running a program. What is actually happening? So code is stored and saved as a file on a computer, typically on a disk drive, but it can also be stored on other mediums like a CD or a flash drive. And this disk or this physical medium is acting as the computer's long-term memory. And so even when you turn the computer off, that program is still there. You can run it again later. Now, when you actually double click on a program and you start running it, that code is being copied from the disk drive or the flash drive or the CD, and it's being transferred to the RAM. And so RAM is random access memory, and the RAM acts as short-term memory for the computer. The reason why RAM exists is because it is much faster than a hard drive or a disk drive. And we're talking like an order of magnitude faster, like way faster than the drive. But the caveat with the RAM is that the RAM is not long-term memory. It is short-term memory, which means that if the power goes out, all of that data is gone, which is why you want to store it on a disk drive, because that's long-term memory. It's not volatile. It will survive a power outage or survive a shutdown of your computer. But when we want to run a program, we want to run it fast. And so the data is transferred from the disk drive or the flash drive or what have you to the RAM, so that we can access the code in that program much faster. But we still actually need to execute the instructions in the code. And that's where the CPU comes in. And so once a program is loaded into the RAM, the central processing unit, or the CPU, will follow the instructions as described in the code. But the CPU has a limited capacity for storing information. The CPU handles all of the actual tasks. It actually executes the code, but it has very limited memory on the physical device, right? So the CPU chip, that's this thing on the left side, that chip can only store a very tiny amount of data. And so it will have to go back and forth with the RAM and read maybe one line at a time, right? It's just reading small segments at a time. And so every single time it gets further down the list of instructions, it needs to go back to the RAM and ask for the next instruction, because it has a very small memory itself. It keeps one or two lines, and then it forgets what it just did. And it just focuses on what's coming on. It focuses on what's coming on next, and it asks the RAM for those additional instructions, those additional things that are happening next. Okay, so let's actually visualize what's actually happening here. So we're looking at a side view of a computer. This is just a normal example computer here, and I've highlighted in this little red box, this is the disk drive. That's where your code is being stored. If you saved it on your computer, it's being stored physically there, right? And so even when you turn off and on your computer, that data is still being maintained. Now, when you double click on a program, you go and run it, the data is being transferred from this disk drive to the RAM. And the RAM are these, it's, I think you might have seen it here. It's these very long chips. Well, they get stored in these long slots that are, they're vertically. You can see there's two of them here. And that's where the RAM is physically stored. And that is the short-term memory of the computer. All right. And then next to the RAM on the left side, you see this big fan here. It says Intel, although Intel's upside down. This fan is on top of the CPU. So the fan is necessary to keep it cool because it gets quite hot. But underneath that is the CPU chip. And you can see with the layout of this computer, it's actually there's a lot of logical reasons about this layout. First, you can see that the RAM and the CPU are very, very close together. That's because when this data is being transferred, it's transferring at basically the speed of light. And if you have a longer distance, it's going to take longer for that information to travel, just physically, right? And so that's why the RAM is as close as possible as it can be to the CPU. Now you can see that hard disk drive all the way over to the right side, all the way to the corner. It doesn't get used. It's not the short-term memory, right? So it doesn't need to be as quick as the RAM does. And so it's okay to have that physically a little bit further away. And there's a little bit more of a distance between them, which means it's going to take a little bit longer for that data transfer to occur. But when the program is actually running, primarily it's data going back and forth between the CPU here and the RAM here. And these are working together to execute your program. All right, so let's go into some code concepts now. There are many, many different programming languages. And so just like how humans have many languages for communication, and I suppose for writing recipes, there are also many different programming languages for giving instructions to computers. And so I've listed some common examples here. This is by no means an exhaustive list. It's a tiny, tiny list. We're just scratching the surface here. But these are some examples that you might have heard of before. Java is a very popular programming language. JavaScript, it's different from Java. Also a very common programming language. Python, Ruby, those are all very popular programming languages as well. These are all different languages. They operate differently. They have different features. Some programming languages can do some things that other programming languages cannot. There are differences. And so you're probably wondering, why would I use one particular programming language, or which programming language should I learn? And the answer is it really depends. It depends on what device that you're programming for, how complicated of a language do you want to be using. Some languages are more complicated than others. And so here are a list of different properties of programming languages. So I mentioned that some programming languages are easier to use than others. And what I mean by that is some programming languages, they're more complicated. They require you to manually perform tasks which are automated by other programming languages. I won't get into the specifics of that right now, but this is kind of why there's been an evolution of programming languages, is because the initial programming languages required you as the developer to do every single aspect of the code by hand. All of the commands that you give to that CPU, all of that had to be done by hand. Then later programming languages started abstracting some of that and started automating some of those very repetitive tasks, so that you as the developer didn't have to manage that, and you would save a lot of time. Now, there's a trade-off here, because sometimes you want to be very, very specific in the commands that the CPU runs. A lot of the times, though, you're okay with how the programming language does that automatically. And you'd rather have code which is less wordy, is faster to write, faster for you to build a completely new program from scratch, over having 100% of the control, but having to spend way more time writing your program. Another consideration is speed. Some programming languages run faster than other programming languages, and it might be okay that your programming language runs slower because it doesn't need to be super fast, and you'd rather it have other features over the speed. There's also compatibility. So I mentioned before in the previous slide, some programming languages require certain hardware. So some languages only work on certain devices. Some programming languages also require other software to be installed on that computer because they rely on those other software components to run. And so if that additional software is not installed on that computer, your program won't run either. And so that's a consideration is you might be programming for like Windows machines, and you use a programming language that doesn't work very well on Windows machines, and so you can't choose that. You have to choose something else. That's a pretty big limiting factor sometimes. And the last one here is functionality. I kind of tied this in with ease of use, but some of the tasks in the programming language, if they're automated and abstracted away from you, then you don't have the ability to be very specific in what you want the computer to do, because some of those commands are handled behind the scenes, automated for you by the programming language. So you can imagine programming languages having their own stats sheets. Maybe if you played like a racing game, you have the speed, you have the acceleration, you have the handling, like Mario Kart or something like that. Programming languages are the same way. Some programming languages are just better for different tasks. Some programming languages are faster, what have you. They're easier to use. They have better handling. But in today's example, we're going to be using JavaScript as our programming language of choice. Now, one thing to keep in mind is that a lot of what we're going to be covering today is going to apply to other programming languages, although some specific details might be different. You might have, certain names or words are different in different programming languages. Some programming languages will use different special characters to indicate similar things in a different programming language. So the goal here for me today is not necessarily to teach you completely programming. There's no way we can cover that in a one session, let alone like 2 or 3 sessions. That's its own course, and I'd highly recommend that you use other online resources to help you learn. But the purpose here today, as I go through these examples and as we talk about programming, is to help you understand these concepts. At the very least, I want to make it easier for you to be able to read someone else's code. If the goal is not for you to write code today, it's for you to be able to read someone else's code. Although I'm sure a lot of you who are very eager to get into this can use the examples as a basis for starting to write some code yourself. And we'll likely have future episodes where we're going to go more in depth and help you along that journey. So let me take a quick look at the chat and see if there are any lingering questions before I start moving on to looking at code. All right, doesn't look like there are any questions so far. So I'm going to start looking at some code examples. I am very certain that you all will have some questions after I start going through these examples. Please ask them in the chat or ask them as a question, and I'll get to them when I can. But don't let any of your lingering questions kind of sit there. We want to make sure that we get all the questions out of the way. All right, so let's go into JavaScript. Now, there are 3 concepts that I'm going to focus on today, and you can see them here bolded on the screen. The first concept is the concept of variables. Now, variables, if you ever remember math from grade school, you remember you might have like, y equals x plus 10 or y equals 2x plus 10 or whatever it is. X and y, those are variables. Now, the same terms apply to programming. A variable is just a name for a value, and that value can change. It can be dynamic. And so variables are a way for you in code to define a specific value that you may want to interact with and manipulate. And you can also name variables. You can name them something more than just X and Y. You can name them basically anything you would like, so that you can keep better track of what that data actually represents. And that's very, very convenient for programming. And it's highly recommended when you are programming to use descriptive variable names, because X and Y, those variables don't really mean very much when you start writing programs that have, 20, 30, 40, 50 pieces of information that you all need to keep track of at the same time. If you're just naming those variables like A, B, C, D, E, you have no idea what anything means. And so we're going to see some examples where you'll have variables that have specific names which indicate something. Um, the second concept we're going to be covering are functions. Now, basically, functions are, this is another thing that you can carry over from math. You think of an example like y equals 2x, for example. That's a function. It is something where it's basically an instruction that can be repeated. And so if you're looking at the example of y equals 2x, you can plug in different x values and you get different y values. And the code, the contents of that function is saying multiply 2 and x together and return a value y. And when you're writing code, it's very, very convenient to basically say, I'm going to have a function, and this is this function is going to perform some task that I'm going to have to perform frequently. And so I'm going to define the function so that I can send it an x value. Maybe I send an x value of 0, an x value of 1, or an x value of 2, and then I'm going to get back a y value. I'm going to get back a return value, which is always going to be the result of executing the instructions in the function. So in math, I think math, those functions are a little bit more simplistic. They usually just have one statement in them. But in code, you can have functions which have multiple statements, multiple components to that, multiple steps, multiple instructions, rather than just one step, one instruction. And we're going to see some examples of that today. Now, the third concept we're going to be covering is the concept of conditionals. Now, conditionals exist to create different paths of logic in your code. And the reason why you have this is because you might find it very useful to say, hey, if this happens, then do something. And if something else happens, then do something else. You want logic which adapts based on the situation. Um, if your code only executes the same thing every single time, then it can't handle anything dynamic. So let's just say you want to build a form and you have two buttons. You have an accept and you have a cancel button. Conditionals allow you to basically have different sets of logic depending on what occurred, right? If someone presses one button, you want to have one set of logic. And if someone presses the other button, you want to perform a different set of logic. And that's why you have conditionals, to specifically facilitate this branching logic, so that it's not like the same code gets executed all the time. Different code gets executed depending on the specific circumstances, the situation that's at hand. Okay, so I also have a little caveat here. The examples today will be specific to JavaScript. And like I said before, a lot of these concepts will apply to other programming languages, but the specific symbols and characters that we use, those could differ between different programming languages. Okay, so I have this code snippet here. It's 15 lines of code, and I'm just going to walk through it one line at a time and explain what is happening here. And we're going to try to reverse engineer, go backwards, and understand what's happening. And so, line number 1 here, we see this line: let space number one space equals space 0 and then a semicolon. And I have the summary here, which is this creates a variable which we're calling number one and sets the initial value. Sorry, this should say initial value to 0, not to 1. It sets the initial value to 0. And breaking down the individual components here, let, this word tells the program to create a new variable. So we didn't have any variables from the very beginning. We're saying create a new variable, and this variable is mutable. Mutable basically means that it can change. So we are creating a variable called number one, and this variable can have different values in our program. Okay, and so let is a keyword, and we need to put a space between let and the next part of our code, because we need the separation to indicate the start and the end of different parts of our code, right? Just like how you have spaces with words with basically any language. We have spaces in programming to denote, the start and end of one word or one character. So we say let is a keyword, then we have a space, and then we have the variable name, number one, and then we have another space, and then we have an equal sign. Now this equal sign is performing what we call an assignment. It is specifically saying, hey, make whatever is on the left side, this variable that we're calling number one, equal to whatever's on the right side. And after this equal sign, we see another space, and then we see the 0 here. And the 0 is a value that is being assigned to the number one. And so now, after this executes, we see we create a new variable called number one, and number one is set to 0. And then we end this with a semicolon. Many programming languages indicate the end of a command, of a statement, with a semicolon. And so we're going to put the semicolon here. It's not really necessary in JavaScript, but it's highly recommended to make your code a little bit more readable. And so we put the semicolon there to indicate that that's the end of the line. So let's take a look at what happened right now. On the left side, I have a table here of the variables, and I'm going to update this as we go through the program. And right now we have this new number one is a variable, and before this line executed, before we ran this line, it didn't exist. There's a blank there, right? But after this line executed, we now have a 0. So the value changed to 0. Okay, so let's go on to the next line. The first 3 lines in this code are very similar, and we're just going to go through it step by step to make sure that we're reinforcing this concept. But please ask any questions if you're confused about what is happening here with variable assignment, creating these new variables and setting their values. Okay, so the second line here, we are still using the word let. That is a keyword here. And we have the space again, and now we're creating, instead of number one, we are creating number two. This is a new variable that we're calling number two. But unlike the first line, we don't have the equals and then the 0. So what's happening here? Well, before, what we were doing is we're setting the value to 0. And in this circumstance, we're not setting any default value. There's no default value. There's a number here, but there's a variable here that we're calling number two, but it doesn't have any value at all. And in JavaScript, when there is no value, this is called undefined. When you have not specifically defined any value at all, it's undefined. Okay. And so now if we look at our table, we have created a number two. That's a new variable, but it still doesn't have any value, right? So in the before and the after comparison here, it didn't have a value before, and it still does not have a value, right? So it's still blank. So now let's move on to our third line. In our third line, we are no longer using the word let. We're now using the word const. Const is short for constant. And so constant means that the value does not change. And so in this instance, what happens is we are creating a new variable that is a constant, meaning that it's immutable, which means that after we set the value, we cannot change the value. And we are creating the variable name called 10, T-E-N. That's the name of a variable. And then again, we have the equals for the assignment of the variable, saying that this new variable that we're creating, we're calling it 10, and we're setting the value to the number 10, right? That makes sense. We called the name of the variable 10, and we are making it equal to the number 10. And then we have the semicolon again. So that's a very simple, like, we've created a new variable. It's called 10. All right. Hopefully that all makes sense. Again, if you have any questions about that, please ask in the chat. So on line 4, we just have a space, a blank. There's nothing there. I did these blanks as a good separation to make it easier to read. So line number 4 does nothing. We go to line number 5. So line number 5, we are doing something different. We're no longer declaring variables. What we're doing is we are doing variable assignment. And so we have here number 1, that's the variable name, equal, and this is very similar to how we did it in line 1. Number 1 is now equal to the old value of number 1, which if you will recall is 0. We set it to 0 in line 1, plus the number 10, right? And so we're literally doing the operation 0 plus 10. What is 0 plus 10? 0 plus 10 is 10. And so that's the result is 10, and we were saying number 1 is now equal to that result, which is 10, right? So number 1 is equal to 0 plus 10, which is 10. Now in line 1, we used the word let. We used the word let because we were creating a new variable that did not exist. But in line 5, number 1, that variable already exists. So we don't use the word let because it already exists. We've already said, hey, there is a variable called number 1, so we don't need to use the let keyword anymore. And actually, if you do use the let keyword, this will cause an error. And so now if we look at our variables, you can see that before we ran this line, number 1 had a value of 0. And now number 1 has a value of 10. So moving to the next line, we have line number 6. So this is very different than what we saw before. And so I'm gonna break it down here. So you can see this console.log. Console.log, that specifically is a function. And if you recall from before, a function is basically just a series of instructions which we want to reuse. And so we say, hey, whatever code is in console.log, save it, and when I use this term console.log, I want to run all of that code that was previously written. And in this circumstance, console.log is not actually something that we created. It is built into JavaScript. It's built into the language. And so JavaScript has this function called console.log, and you can call it, and what this will do is it will print out the value that you give it. And so we have console.log, and then we have an open parentheses. And then inside the open parentheses, we have number 1, and then we have a closed parentheses, and then we have a semicolon. And so what is happening is that these parentheses do what is called calling or executing the function. It's basically saying, run the code in the console.log function, and whatever's in the parentheses, we're going to send to that function for it to operate on. Because the purpose of console.log is to print the value that you send it to the screen, it's important that we send it a value to print, right? Because otherwise, if we called it, it doesn't have anything to print to the screen. And so you can actually put in the values that you wanted to print within these parentheses here. So simply put, this line will print out the number 1, which is in this case 10. We move on to line number 8. And now you can see that number 2 is being assigned. And we say number 2 is equal to number 1 times 5. And if you recall, number 1 was previously set to 10. And so what is the value of number 2? Hopefully you can do the math. It's 50. And so we update our variable list here. Before we executed this line, number 2 had no value whatsoever. And now it has the value of 50. And moving forward now, you can see that we do another console.log, but instead of printing number 1, we are printing number 2, which is 50. We go to line 11. We have number 2. We do another assignment, right? Number 2 is equal to number 2, and then we have the forward slash here. That's divides. So number 2 divided by 10. So what was number 2? So number 2 was 50. And now we're dividing it by 10. And so this means that number 2 should be 5. And so we've updated the value of number 2. It used to be 50. Now the value of number 2 is 5. We print out number 2 again. The value is 5. And we move on to the next line here. And we're now doing another assignment to number 2. We say number 2 is equal to number 1 minus number 2. And so now we have to remember, what was the value of number 1? Well, number 1 was 10, and number 2 is 5. So we are doing 10 minus 5 is 5. And so number 2 is now 5. Now, it was previously 5, and we've just updated back to 5. So there really isn't very much difference here. But this will execute nonetheless. We now have a value of 5. And we print that out once again, and we will get 5. So right now in this code, what we've basically done is we've covered some fundamental concepts here. We learned that there are 2 words that we can use to create a variable. We can use the word let, and we can use the word const. Let creates a new variable that can be modified and changed. Const creates a variable which cannot change. It is immutable. All right, if we tried to change the value of 10, it would have caused an error. Something else that we learned is that you can set the value of a variable by using the equal sign. So when you have a variable on the left side, you can use equals, and on the right side, you can provide a new value that you would like to set the variable to. We also learned that you can use various math symbols to perform basic math operations, and these include the plus, the minus, the asterisks is the multiply, and the forward slash is the divide sign, and you can use those to perform basic math operations. We also learned that functions can be called by using their name with parentheses. These parentheses specifically indicate that you want to execute the code within that function. And we did that with console.log. And we actually put in values that we wanted console.log to use in the instructions. And we also learned that you should end each command with a semicolon. So those are some basics. Now let's get into something a little bit more complicated. Let's actually try to create some functions of our own. Okay, so I've got a new set of code here. And what we are seeing is on this first line is that we're creating a new function, and we use the function keyword, and you can see with my coloring, because it's a special keyword, it's yellow here. It's got a different color. And we are calling our new function add3. And we're calling it add3 because what it will do is it will add 3 to the number that we send to this function. So to create this function, we say function space, and then the name that we want to give this function. The naming on this behaves the very similar way to the way that you name variables. You just come up with a name that you would like, and when you use that name, it refers to that thing. And so we say we're creating an add3 function, and then we have the parentheses again. And within the parentheses, we have the word number. And within these parentheses, this is where we put what we call our input variables or parameters. And basically, these are the values that our function will take and use in the code within the function. And so we have an add3 function. We need an input number for us to add 3 to, because if we don't have the input number, what do we do, right? And so you can imagine this. If you go back to the math example, you have like a y equals x plus 3. This is a very similar concept to that, right? In this case, that x value is the number here. We're calling it number. I could have also called the variable x instead of calling the variable number. The choice to call it number was my choice. I can call it whatever I want. And so you can see that we have the function, the add3, the parentheses, and then we have number in there. And then we have this little squiggly curly brace. Now, if you haven't seen code before, you haven't been programming before, this is probably a strange character that you're probably not using very frequently. But the curly brace here, this open curly brace, denotes the start of the contents of your function. And so we say everything that comes after this is the contents of the function. So that's what's happening on this one line. In this one line, just to recap, we are creating a new function. You create a new function by using the function keyword. After the function keyword, you specify the name of the function. And then you have these parentheses, open and close parentheses. And within the open and close parentheses, you put the list of variables, the list of input parameters that you want to use inside your function. And whoever calls your function needs to give you those variables for you to use. And then after the parentheses there, we have the curly brace. The curly brace indicates that everything that comes afterwards, that is the contents, that is the substance, that is the code of my function. When someone calls my function, we are executing all of the code in between my curly braces here. Okay. And just to skip a little bit forward, you can see on line 3, we have a close brace. That close brace matches up with the open curly bracket, right? If you have one open, you need one close, because if they don't line up, the computer is not going to know where one thing ends and one thing begins. So let's go on to line 2. You can see a new word that we haven't used before, which is called return. And return specifically indicates that whatever follows is going to be the result of our function. And whoever called our function is going to get this value that comes after return. And we say return space number. And if you remember, the number here is the input parameter. And then we do +3 semicolon, right? So whatever the number is that someone's calling our function with, we're going to do +3, and that is going to be what we send back to whoever called our function. Another thing to note with this line is that you can see it was indented, right? It's there's some space between where the return starts and the start of the line, right? The reason why you do this is it helps. It's not necessary in JavaScript, but the spacing here helps you identify this section of code belonging to the function add3. If there's more logic within your code, you can have more brackets that will get nested, and you will need to use more indents and more spacing to help you line them up. It's not evident in this example, but in future examples, you'll understand why that's necessary. Just know that every time you use a curly brace, you should indent the subsequent lines by 1, indent it by 1 tab typically. And then every time you see a close brace, you start unindenting by 1 tab. That's a stylistic thing. It's not required for JavaScript to run, but people code that way just to make the code easier to read. Okay, so now we have our line 3, which indicates the end of the add3 function. I mentioned this before. That's the curly brace close. And so this means that in lines 1 through 3, we define this add3 function, which will just take whatever you give it, and then you add 3 to it, and that's what gets returned. And then now we have some additional lines here. Line 5, you can see console.log. So what we're doing is we are calling console.log, and we are sending the value of whatever add3 0 is, and that's what we are sending to console.log. And so when you're looking at add3 is going to return 3, and 3 is going to be what gets printed. So add3 resolves to 3, the 3 gets sent to console.log, and then you print out 3. The next line, pretty self-explanatory, add3 function with the value 1. We do 1 plus 3, that's going to give you 4. We print out 4. The next line, we call add3 with 3. That does 3 plus 3, that's 6. It prints out 6. So hopefully that all makes sense. So let's recap that, right? So what we learned is that the function keyword can be used to define a new function. I think that makes sense. We also learned that an open curly bracket is used to denote the start of a function's contents, and that a closed curly bracket can be used to denote the end of a function's contents. And we also learned that the return keyword is used to indicate the value that is being sent back by the function. All right, let's look at one more example, and then we're going to do a quick demo and show you how you can actually start writing some code on your own computer. All right, so now we have a more complicated function, and you can actually see some of the additional tabs, the spacing that I mentioned before. But let's break this down one step at a time. So again, we're seeing something very similar to what we saw with the previous code snippet. We have a new function here, and we're calling this new function sign, and then sign will take in a number. And so we have function space, the name of the function, which is sign, the parentheses, which take in the value number. We have the open curly bracket, which indicates the start of the contents of the function. Try to guess by yourself right now, actually, what do you think the rest of this code is actually doing? Make a educated guess, and then I'll step through this. But just take a second here, try to guess what this code is actually doing, and then see if it lines up to my explanation here. Okay, so on line 2, we are seeing something new, which we haven't seen before. We're seeing a new term, a new keyword called if. And the if keyword indicates a condition. And so specifically what we want to be doing here is we are going to change the code that gets executed based on current conditions. And the if statement specifically indicates that, hey, we're doing a check, we're going to check for a value, and then we're going to change directions depending on what the value is, right? And so what follows is these parentheses. We have an open parenthesis, and then we can see number space greater than space 0. So what is happening is we are defining the condition of this if statement. And we're saying if number is greater than 0, then do something. But the condition number greater than 0, this is put in these parentheses. The parentheses let the computer know that you are checking for this statement is number greater than 0. Okay. Following that, we have a curly bracket again, another open curly bracket. And so now this is specifically saying that if the condition is true, if number is greater than 0, then execute the code that follows this curly brace. And so you can see here the open curly brace. On the next line, we've indented because we want to indicate that the code that follows is associated with the if statement specifically. So we indented 1 so that we can specifically say anything that's indented 1 from this if statement belongs to the if statement above. And what we're doing is we are returning, and then you can see the return like we saw before, and then you see these quotes, these double quotes. Double quotes are used to indicate what is called a string, which is basically just text. And so the computer needs to be able to determine the difference between commands that you are giving it and text, right? Because we used if in the previous line to indicate that we're checking for a condition. What if we want to use the word if in some text and we want to print out the word if? Well, the way that you tell the computer program that you want this to be text is you put it in these double quotes. And so we have the double quotes and we say the word positive, and then we have the semicolon at the end indicating the end of this statement. And what is happening here is that if the condition in line 2, if number is greater than 0, if that is correct, if that is true, then we are executing this line, which is return positive. So this function will return the text positive if the value of number is greater than 0. If not, then what happens is we have this else statement, the else if. And so our logic for what happens in the case that number is greater than 0, we are terminating that logic right now. We're saying we're returning positive if number is greater than 0. So we need to have a close brace, close bracket to indicate that our logic for what happens if number is greater than 0 is come to an end. And now we want to define another condition. This new condition, we're saying else if, and so this means, in line 2, we're checking to see if something is true. And we're saying in this line, else means if not true. But what was happening is immediately after else, we are chaining another if. We want to say that, hey, if line 2, if that condition isn't true, then let's check for another condition. So else if, and then we have the same condition. We have the same way that we defined the previous condition. We have the parentheses here, and instead of saying number greater than 0, we're saying number less than 0. And so now we're adding a second condition here. We're saying if line 2 is not true, then let's check to see if line 4 is true. Let's check to see if number is less than 0. And then we have the open curly brace again. And now instead of returning positive, we're going to return negative. And then we're finally closing out that logic with another curly brace, but we're not adding a new condition. We're not doing another if check. We are just saying, okay, if it's neither positive nor negative, we're just going to return neither, right? And so if you haven't figured out right now, this code snippet is checking to see if to get the sign of a number. Is the number positive? Is the number negative? Or in this case, if it's neither positive nor negative, it's neither, right? And so that's the logic here. We are able to change the behavior of our program based on a specific condition. And so now we're seeing these two curly braces here. The first curly brace corresponds to the curly brace in line 6, the open curly brace in line 6. And so remember, anything in the curly brace, that logic is being assigned to what happens immediately prior to that, right? So in line 6, we have an open curly brace. In line 8, we have a closed curly brace. Everything in between, that is what gets executed in the else statement, this final else statement. This curly brace in line 9, that indicates the end of the function because this curly brace lines up to the curly brace in line 1. And so every time you open a curly brace, you specify, hey, this is a new chunk of code. And then every time you use a closed curly brace, you finish the logic of the most recently opened curly brace. So in line 6, we open logic. In line 8, we close logic for that else statement. In line 1, we open logic for the function, and in line 9, we close logic for the function. This might be a little bit hard to comprehend until you start playing with it a little bit more, but just remember that open and closed curly braces, they need to correspond with each other. Okay, so line 11, we're actually calling the function. And so we're doing console.log just like we had in the previous examples. And we're calling the sign function, and in a line 11, we're calling it the value 1. And so we're checking, we're calling it with the value 1. And what's going to happen is number is going to become the value 1. And in line 2, we check, is number greater than 0? And it is. 1 is greater than 0. And so this function returns the word positive, which means that this program is going to print out the word positive. So let's go on to line 12. We run the sign function with the value of -1, which means that number is now -1. And so in line 2, number is not greater than 0. And so it moves on to line 4. And in this circumstance, number is less than 0. And so sign returns the word negative. And so when we call sign with the value of 0, number is 0. 0 is not greater than 0. 0 is also not less than 0, which means that we print out neither. All right. So this is the recap of what we learned just now. Conditions allow us to create this branching logic based on the state of the program, right? We created a sign function and we said, hey, if this number is negative, we want to do this. If this number is positive, we want to do this. If it's neither negative nor positive, we want to do this. And we can use the if, the else if, and the else to create these logic branches. We also learned that the conditions of an if statement are contained within the open and close parentheses, right? So the parentheses are used to specify the condition, and the braces, the curly braces, are used to denote the start of a function or a condition's contents, and the closed bracket, the closed brace, can be used to denote the end of the contents, right? So when we were in this code, we were in this code here, all the logic that we wanted to execute if a condition was true or if a condition was not true was contained within the corresponding open and closed curly braces. And then we also learned that the return keyword is used to indicate that a value is being sent back by the function. Another thing to actually note as well is that the return keyword ends the function. So anything that, any logic that would be executed after the return does not happen because the return says, that's it, I'm done with the function, goodbye. All right, so these examples, they're all specific to JavaScript. That's my final disclaimer here. Now let's actually go and play around with some real code. All right, so I'm in here, I'm in my Kali machine. JavaScript is nice because you can get it to run basically like anywhere. In Kali, what I did was I installed sudo apt-get installed node. You can do this. This will allow you to install something called Node.js. I think actually maybe it's called Node.js. Yeah, Node.js. So you can type in sudo apt-get install Node.js. This will install the Node.js program, and the Node.js program will execute JavaScript code. Another thing that you could do as well, you can open a browser, and if you hit F12 or if you go and right click and do inspect element, you can get a Java terminal. Java runs in the browser as well. And so you can go get a console here and you can start writing code just like this. So there's a lot of ways for you to start writing JavaScript code. You can install Node.js like I show you right here. Sudo apt-get install Node.js. I already have it installed, so I don't need it to do anything. Or you can open up a browser and execute code on the browser. Now, one caveat with the browser method. Whatever page you're on, you are executing code on that page. There are a couple like phishing scams out there which will ask you to like copy their code and paste it in your browser. And what it's doing is it's sending your passwords to someone like that. Be very mindful of that when you're copying code. Like, you are executing it in your browser with all of your browser settings on whatever page you're on. And so you might be executing malicious code and giving away some sensitive information. So if you want to play it safe, I'd actually recommend running code in Node.js using the command line like I'm showing you right now. So I've installed Node.js. You can type in Node to start running it. And now we have we have a prompt right now for Node.js. And so let's do what we did before with declaring variables. And so let me say um, let's say let big num equal 100. So we're creating a big number, and big number is 100. And then we can say const, let's call it 10 because we did that before. Const 10 is equal to 10. Okay. So I mentioned before that if you use the const keyword, you can't change the value. And so let me actually show you an example of that. If I do 10 equals 1, this gives me an error, right? It says uncaught type error, assignment to constant variable. That's the error. You cannot change the value of a constant variable, but you can change the value of a not constant variable, one that you create with let. And so now I want to say, let's make big num equal to 1,000. Now big num is 1,000. Cool. Let me show you the console.log. We do console.log, and then let's print out big num like that. You can see here, we printed out 1,000. Now you're probably asking, what is this undefined thing that keeps showing up? When you use the terminal, the Node.js terminal here, whatever the return value of the function is, that is what gets printed after you execute the program. And so when I did console.log bignum, this printed out the value of bignum, but then when console.log returned, it didn't return a value, which is why we see undefined here. Okay, so I am going to recreate our sign function. And so let me do that right now. I'm going to create a new function, and we can say, let's call it sign like we did, and we took in a number. So now and let me actually increase the font size here so you all can see this a little better. 26. Let's try that. All right. Okay. So we are creating a new function. We're calling it sign, and it's going to take in a number. And then we have the open curly brace to define the start to our function. And then what we're going to do is we're going to actually say if num is greater than 0, then what we want to do is return positive. And then we do the close brace here to say that that's the end of the if statement. And then we're going to say else if num is less than 0, we have another open brace for the next set of logic. And we're going to say return negative, close brace, else return neither. And then let's make sure we line up our braces, right? So this brace lines up with this brace. So anything, when this condition is true, this code gets executed. Then we have a new condition. This brace lines up with this brace. If this condition is true, then this gets executed. We have another condition here. This brace lines up with this brace. This code gets executed. And so all of these lines have corresponding braces, which means that we now need to end this function, and I'll end it with another close brace like that. And so now we have this function called sign. And if I type in sign like that, you can see that JavaScript is identifying that this is a function that we called sign. And so let's call sign console.log sign of 1. The sign of 1 is positive, right? We can see that it printed out positive. So that works. Now, we are right now using the terminal, which means that whatever we're typing it's not getting saved, right? It's just here's the code, execute the code right away. None of this is being saved. If you want to write a program that can be saved, what you can do is you can just open a text editor. And so I'm going to use, let's create a text document. We're going to call it myprogram.js. And then I have my program.js. I'm going to open it with the built-in editor here. Is there no built-in editor? All right. Well, it's not opening, is it? Oh no, here it is. Silly me. I have my notes from last episode, which is why I didn't notice it open. So we have a program here. I can create my function. I can say function. Let's do something different this time. Let's say we're gonna create some logic. We're going to do an we're going to create a function which will return a value where we square the value that gets sent in. And so we're going to call it square. And so we'll take in a number. And then I always, when I create an open brace, I always create a corresponding closed brace so I don't forget to do that. And then what we're going to do is we are going to say return number times number, right? Because when you square something, you multiply it times itself. And now what we can do is we can say console.log squared, and then let's just say, let's try it with 2, console.log squared 4, console.log squared 10. All right. I'm going to save this program. And then to run a program with Node.js, you just type in Node and then the name of the program. You have to give it the correct path. If you try to run a program using its name and it's not in your current folder and you don't specify the path properly, it won't find it. It'll give you an error. So if I just do this, you can see here, it gives me this error. So what I'm going to do is I'm going to type in Node, the name of the file. The name of the file was myprogram.js. I run this program and you can see it ran my code. It did 2 squared. 2 squared is 4. 4 squared. 4 squared is 16. 10 squared. 10 squared is 100. So we can see that our code actually worked. This is very, very basic, but hopefully this has been very helpful to learn just those concepts of how does code actually work, right? How do you create a variable? How do you check different conditions? How do you write a function so you can reuse that logic, right? I wrote one function to square every number that I want to square, right? If I want to square 2, I can square 2. I want to square 4, I can square 4. I can square as many numbers as I want. And I don't have to rewrite that logic of number times number. I wrote the code once and I could reuse it as many times as I want. So now you have the knowledge to maybe automate some basic calculator tasks. But this is the basic. If you all liked this, let me know. We can do a more comprehensive episode next, and we can get into more sophisticated things with coding. But try reading some code. Online you can find a lot of code samples. I've seen some people asking what resources can you use to code. There's Code Academy, Pluralsight I've seen. There are so many different places out there that you can even find like GitHub repos which have guides and coding projects for you out there. So I'm sure there's a lot of people who can recommend a lot of things. I personally started with I personally started learning JavaScript and Node.js using Code School, which got bought by Pluralsight. You can also use Code Academy. Some of those are free, some of those are paid. So take a look and figure out what makes the most sense for you. But hopefully you all found today's episode helpful. I'm going to start putting up a poll asking if you all want more coding episodes. And we'll see what you all say. If there's interest in it, the next episode we'll do will be a coding episode. We're gonna start wrapping up for the end of the year soon because we're we're getting to Thanksgiving. We're getting close to December. Love to cover a little bit more of this, but we probably will only have like one episode left in December before the end of the year, and we'll come back again in January. But hopefully you all found that helpful. If you have any questions, any concepts that you want us to cover in a future episode, please let us know in the chat. But otherwise, thank you all for joining us today, and hope you enjoy the rest of your week. We got Thanksgiving coming up next week. Hope you have a great Thanksgiving. And with the holidays coming up in December, wishing you happy holidays as we get into holiday season. So thank you all once again. Enjoy the rest of your day. Until the next episode, take care. Thank you very much.